In this video, you will learn how to factor trinomials when there is a coefficient in the front of the quadratic term. So something like this, where we have a times x squared. All right, so here, for example, we have 2x squared minus x minus 6. This is different than the ones we've been doing because now there is a coefficient in front of the x squared term. So this makes it more difficult to factor. So when I factor, I know that I'm going to have two binomials multiplied together. And I need to think through what's going to go in these four different spots. Well, I know the first two would multiply to give me the first term of 2x squared. So I need to think through what two things would multiply to get 2x squared. So what are the factors of 2x squared? Well, the only way to get that would be by taking 2x for one of them and then x for the other, because 2x times x would give me 2x squared. So we know that we need a 2x and an x right there. So then the question comes down to what numbers go here and here. So to determine that, we need to think through the fact that they need to multiply to get this last number of -6. So we now need to ask ourselves, what are the factors of -6? So what can multiply to get -6? Well, we see here it could be 1 times -6, -1 times +6, +2 times -3, or -2 times +3. So the question is, which numbers are we going to use? So it's not as straightforward as the other problems when the coefficient's not bigger than 1. With the 2, we cannot just look here and see, oh, 1 plus -6 is -5. That doesn't work because this is -1, because we need to account for the 2 over here. So we cannot just look at this point to determine. We need to actually experiment by plugging these numbers in to determine which one would give me back out the middle term. So any of this would give me this last term of -6, and we have the first term taken care of. So the question really comes down to which ones would give me a -1 when I plug it in. So I can trial and error. So I know it's got to be a 2x and x at the beginning. I can try +1 and -6, this first one right here. Well, we know the first and last terms are good with this setup. So the question is, what about the first power term, the linear term? So this middle one right here. Well, to check that one, we can think through distributing, but I don't need to distribute every single part because I know the first and last are okay already. So if I wanted to, I could just do the inner and outer. So 1x and then 2x times -6 is -12x. So -12x plus 1x would give me 11x, or -11x, which does not work here for this middle term. So this one does not work. Okay? Now we do need to experiment still with the same numbers, 1 and -6, but change where they're located, because it will make a difference. So instead of a 1 with the 2x, I put the -6 with the 2x. So if I multiply the -6 times x and the 2x times 1, we have -6x plus 2x, which is -4x, which still does not work for that middle term. Now we can experiment with -1 and +6. So plugging -1 and +6 in, if we check the middle term, we find that we have -1x plus 12x, which would be 11x. So that one still does not work. So I need to switch again the -1 and 6 and put the 6 with the 2x and see what that does for me. So if I check this one, 6 times x is 6x, 2x times -1 is -2x. Those would add to get 4x, which does not work either. All right, next I need to try this third set of factors. So we plug a 2 and -3 in. So 2 and -3. We need to check to make sure the middle term would work okay. So we can do the inner and outer, 2x and then -6x, and that would give me -4x, which does not work. Okay, now we need to try the -3 with the 2x, see if that one works. We check the inner and outer. Negative 3 times x, and then 2x times 2 would give me 4x, and then negative 3x, which is a positive 1x. So we're close. We want a negative 1x. So we actually could just switch the signs. So instead of negative 3 and positive 2, we could try positive 3 and negative 2. And we see that one right here. Positive 3 and negative 2, they would multiply the inner and outer to get 3x and negative 4x, which would give me negative 1x. So after all of this, we finally find that our answer, the factored form of the original expression, would be 2x plus 3 times x minus 2. So this is the trial and error method. So we just plug in numbers to see which ones will work. And it can be pretty tedious, but as you get some practice with it, you can learn, you can pick up on this pretty quick. And there is another method that we can show you in a later video that involves what's called factoring by grouping. But to understand that, you need to understand how to factor by grouping first, and then you can use that second method. Okay, here's another example. We have 10x squared plus x minus 3. So when I factor this, I know that I need two binomials in parentheses. So we need something to fill each of these spots, and we can begin by looking at the 10x squared. We know the first terms multiply together to get the 10x squared. Well, to get 10x squared, what different ways can we have 10x squared? So the factors of 10x squared would be 10x and x. So it could be 10x times x to get 10x squared, or it could also be 5x times 2x, because those would also multiply to get 10x squared. So we know that the first sets of numbers or values need to be either one of these two. So that would take care of the first term. And then for the last term, we need to get negative 3. So we can get that by multiplying these last numbers together. So whatever these are, you multiply them, that would give me negative 3. So how do we get negative 3 when we multiply? Well, we could have positive 1 times negative 3, or negative 1 times positive 3. So that would take care of the last term. So the question is, which combination of these do I want to use to get a positive 1 back out for the middle term? And once again, I cannot just look here at the 1 and negative 3 to determine if these work to get 1, because obviously this would add to get negative 2, this would be positive 2, neither of which give me 1. However, we need to account for the fact that we have a coefficient with the x squared. So we cannot just look right here, we need to actually plug in numbers and values to determine which one will work. So we can do trial and error. If we experiment with the 10x and x in the first terms, we can then try the 1 and negative 3 for the last terms. So that combination would give me back out the first and last part. The question is, will that give me this middle term of positive 1x? So I can try by multiplying the inner and the outer. So we could distribute everything, which is not necessary because we already know the first and last terms are going to work. So I can just do the inner and outer if I wanted. So multiply 1 times x to get 1x, and then 10x times negative 3 would give me negative 30x. So we add those together to get negative 29, which does not equal the 1x that I need. So this would not work. All right, I can move the negative 3 with the 10x instead to see if that makes a difference. So move that over here, and we know that still the first and last terms would work fine. The question is, do we get back out a 1x? So I can check that by checking the inner and outer. So we have negative 3x and then plus 10x. Those would add together to get 7x, which is not what I need. All right, so then I could experiment if I wanted with now the negative 1 and positive 3. but I can tell you already those will not work because all we're doing is we're changing the sign. So what's going to happen is this, for the first one, if we switch the sign, this would become a positive 29x, which still doesn't work. And then switching the signs here for the second one would give me a negative 7x, which still does not work. And we can do that, and we see here that's what we do get. So we can now eliminate the possibility of it being a 10x and 1x. We tried all the combinations. So now we need to try 5x and 2x. So we can plug a 5x and 2x in for the first terms, and then try the 1 and negative 3. So trying the 1 and negative 3, first of all, we know the first term and the last term will be taken care of. The question is if we'll get back out the 1x. So to check that, we can do the inner, 1 times 2x, and then the outer, 5x times negative 3. If you add those together, the negative 15x plus 2x, that would be negative 13x, which does not work. So nothing has worked so far. We could try switching the 3 and the 1. So put the 3 over with the 5x and the 1 with the 2x. So trying that, we can check the inner and outer. We get negative 3 times 2x, which is negative 6x, and then 5x times 1 is 5x. So negative 6x plus 5x would be negative 1x, which is very close, but it's a negative, not a positive. So this one does not work. But since we see that the sign is the only thing that's different, if we just change this to a positive 3 and negative 1, then this becomes a negative 5x and positive 6x, which would give me a positive x. And we see that right here for the last one. That is what would happen. So my factored form would be 5x plus 3 times 2x minus 1. So it's a lot of work to trial and error, but you can kind of pick up on some shortcuts to eliminate different possibilities. Here is another example where now we have two different variables in the quadratic expression. So we have x and y in this case. Now the process is still the same. So we know to factor, we need to have a set of binomials. And the question is, what goes in these blanks? So to get the first term of 5x squared, we know we multiply these first terms over here together. So the question is, what would multiply to get 5x squared? Well, to get 5x squared, we have 5x times x. So we know one is going to be 5x, the other is going to be 1x. So that takes care of the first term. And then the question is, what goes for the last two numbers? So looking just at the number part, we need 21. All right, so to get 21, we could have 1 times 21. We could actually have negative 1 times negative 21. Those would multiply to get a positive. Positive 3 and positive 7, or negative 3 and negative 7 would all give me a positive 21. So the question is, which set of these do I want? All right, so I need to experiment. So we could plug in a 5x and x, so we know that's got to be there. If we do negative 1 and negative 21, okay, that would multiply to get the last term, so that's good. And then to take care of the y, if we put a y in both of them, y times y would also give me the y squared. And then when you do the inner and outer, we would have negative 1xy and then negative 105xy. And that would add to give me negative 106xy, which is not the right number, but it looks, it's going to be a like term with this. They both have xy's. So this is the correct format where we have a y in each of these. So experiment now with other numbers. So we tried both negatives. All right, so switching the sign isn't going to help. And actually we want it to be both negatives because if they're both positive, there's no way to get negative 26 if they're both positive. So we know it cannot be positive 1, positive 21. We actually know it's not going to be a positive 3 and positive 7 for the same reason, because we need a negative for the middle term. So it's got to be one of these combinations. So we can try switching the 1 and the 21, so the 21 is with the 5 and the 1 is with the x. So if we try that, we test the inner and outer, we get negative 21 xy and then minus 5 xy. And look, that would give me negative 26 xy, which is what we wanted for that middle term. So here, this would be my correct answer, 5x minus 21y times x minus 1y. And we could double check by multiplying back through, and we'd find that this would be correct. And we could experiment with other ones and find those are not the correct answer, but this second one is.